Name the arc made by the given angle. All right, so I'm given these pictures, and there's ways that you can name arcs. Okay, an arc in a circle is basically, if you were to look at the outside of the circle, if I were to go from A to B, I could name that arc AB. But what if I add all these different letters? And what if I want to be more specific? Like, for example, if I were to say arc AC, which way am I going? Do I care about the right side, ABC, or ADC? Well, I can name these guys. Like if I want this portion of the circle, right? And I want to name that arc, I would call that arc, and here's my arc symbol, arc ADC. If I wanted just this one, which is called a minor arc because it only involves two dots, I would call that arc BC or arc CB. So, by calling this arc BC, I know that I'm going right from B to C and I'm not taking this long way around. So that's how you can name the arcs. So when I'm looking at this guy right here, the name of the arc made by the angle FQE, here's F, here's Q, here's E. Well, I have three dots on my circle, but I'm going straight from F to E. So there's two names for this one. I can either call it FE or EF. I'm not including D because I'm only going in this short route to get from F to E. I'm not including the whole circle over here. Similarly, angle 1 is between I and H, and I don't care about J. So I can either call this high or I can call this eh. Either way, I'm not going to include the J. So when I'm reading these, I'm looking at the letters, and that's kind of telling me the direction that I'm going in which part of the circle that I care about. Okay, so that's how I name arcs using angles. Name the central angle of the given arc. A central angle is the angle that basically its vertex is the center of a circle. This area is called a sector, not that it matters. These are arcs, okay? Now, I'm given arc ML. So it's basically saying I want to go straight from M to L. Should I go this way? No, because otherwise I would have snuck a K in there. This is just ML, so I care about right here. And the angle created by me going from M to L is just angle 1. Okay, nothing to think, nothing to overthink. Pretty simple. Okay, likewise, again, I'm not being really creative with my letters here. ML just goes from here to here again. Okay, now that is this angle right here. I'm not including K, so MQL would be the name of this angle. I could call it LQM. It really doesn't matter. Either one, MQL or LQM, both of those work, but the central angle is basically your vertex is the center. Pretty simple. Find each measure. First things first, I'm going to find the measure of arc CFD. Before we talk about that, I have a lot going on with these circles, so let's try to understand things. If I have a central angle right here, a central angle means its vertex lives on the center of the circle. And if I were to create an arc, and we'll call you A, we'll call you B, we'll call you C. If I were to say, well, let's call angle ACB 80 degrees. Whatever the central angle is, the arc measurement is exactly the same thing. So if an arc measure creates a central angle, AB, I have 6 of those, the central angle is going to have the same exact measurement. ACB or BAC, or BCA, I mean. Basketball Club Association. So 80 is 80 in this case. Now, when I go over here, CFD is just more complicated than I need. CFD means I'm going around here and around here and also here and also here. And if you're wondering, why didn't they call it CBD or CBFED or CED or DF? Well, basically, this is just saying I need to go from C to D, but I have to include F. That's why I'm not just including this little chunk here. Now, what I have is basically all of this right here. Problem number 1. I don't know U, and I don't know U. But what I do know is FC appears to be a straight line. And if FC is a straight line, then these two angles are going to be supplementary, which means they add up to 180 degrees. And if these two angles are 180 degrees, then you're 45, which also means vertex angles, you're 45. Oh. So the measure going from C all the way around to D is going to be 45 plus 135 plus 45 plus 81. So 45 plus 135 plus 45 plus 81 is 306. So the measure of angle CFD is 356 or 306. I kind of Freudian slip. That's also true. That's very true. But what that means, and most importantly, is that means the measure of arc CFD is 306. So I caught myself. I mean, I was accidentally naming the wrong thing, but by saying this, I can kind of like pretend like I know what I'm doing and be like, yeah, I was trying to do this the whole time, which I am. Let's see if this one's a little bit more friendly. The measure of angle MIJ. MIJ is this angle right here. I don't have any angle measurements. I have this arc measurement, and arc JK is 55, which means its central angle created by it, what is that, JIK, is also 55. So if you're 55 and this is a straight line, these guys add up to 180. So the measure of angle MIJ is 180 minus 55, which gives me 25. 125 degrees. So I'll put that up here to keep things consistent. The measure of angle MIJ is 125 degrees, which means the measure of angle of arc MJ, Michael Jordan, is 125 degrees, and so on and so forth. So central angles being matched up with their arcs, everything's the same. That's one of the nicer parts about circles. Solve for x. All right. What do I have? I have this guy, which is I almost called it ratio, a radius. This guy is a diameter. I have this angle, which equals that angle. If this is a diameter, that means this angle is 180 degrees. If these two are equal, that means you're 90 degrees. So the way I can set this up is x plus 93 is 90 degrees. It's a one-stepper. Just subtract 93 from both sides. And x is negative 3. Now, don't be like, negative 3, you can't have negative measurements. X is not a measurement. It's just a variable. So that if I wanted to find x, I would be like, negative 3 plus 93. Oh, this is 90. That arc length is 90. Yay, I did it. So that's how you would do a problem like this. Not too bad. Not too bad at all. Find the given measure. I have to find the measure of angle VST, which is U. Now, what I know is the arc measurement of VU is negative 27x minus 3, which means the central angle created by that arc is going to be the same exact thing. Also, since this angle is congruent to that angle, both of these are negative 27x minus 3. And last but not least, this central angle creates this arc negative 37x plus 2, which means you're that guy right there. So this right now, just saying each of these individually, trying to find things, isn't going to help me find x, and in other words, help me find this angle VST right here. But what I do know is I have all three angles that create an entire circle. So why don't I add up all the angles and set it equal to 360 because the circle's angles add up to 360. So let's do this angle right here, negative 27x minus 3. Let's say it again. So I could put a parentheses in front of it. I can distribute, but I'll just write it out. Negative 27x minus 3. Now this guy minus 37x plus 2 has to equal 360 degrees. Okay? Now let's combine like terms. Negative 27 minus 27 minus 37 is negative 91. So negative 91x. Negative 3 minus 3 is negative 6, plus 2 is negative 4, so minus 4 equals 360 degrees. Now it's a two-step equation. I'm going to add 4 to both sides. I'm going to add 4 to both sides. So negative 91x is equal to positive 364. I'm going to divide both sides by negative 91. And x is going to equal negative 4. Am I done? No, because my job is to find the measure of angle VST. The measure of angle VST is this guy, which happens to be the same as negative 27x minus 3. So if I wanted to find the measure of angle VST, I'm going to do negative 27, replace x with negative 4 minus 3. Negative 27 times negative 4 is positive 108. And 108 minus 3 is 105. So the measure of angle VST is 105 degrees. And there you go. Not too bad. Not too good, but I like this stuff. This stuff's fun for me. Fun, fun, fun. Fun. Find the length of this segment indicated. All right, when you're looking at a circle, you have a diameter. A diameter is a line that goes completely through a circle. You have a radius, which is a line that connects the circle to the end of the circle. And you have a chord that just basically goes from one point to another point. Those are your three lines mainly that you're dealing with that just live solely within the circle. What I have is I have a radius, which is 3.2. I have this line that if I were to keep it going would also be the radius. But more importantly, my radius goes through a chord. There's a little rule that says that if your radius goes through a chord, it bisects that entire chord. And when you bisect something, x is going to equal 3. Whatever this is going to equal that guy. So with all this math, x equals 3. So nothing here to overthink, nothing here to just do too much with. X equals 3, donezo. Find the length of the segment indicated. The segment that I care about right here is x. I'm given all this information. Diameter, another diameter. Here's a chord. I'm also given the fact that here's a radius, radius, a radius, and they're all 9.7. Now that's important. Not the fact that I give you 3 radii. I don't care how many radii I get. By the way, I did say radii, not radio, radii. Okay, video killed the radii star. That's a song. Look it up. But regardless, radius is 3.7. I care about x. But what I do know is, again, and it says it 3 times, the radius is 9.7. So that red line that I just drew is 9.7. So if I wanted to find x, x plus 5.1 equals that entire radius, 9.7. So if I subtract 5.1 from both sides, x is going to equal 4.6. No units to worry about, no units at all. But there I have it. I mean, you should be able to look at this and be like, well, if that's the radius, don't I just do 9.7 minus 5.1? Yup. And that's it. That's all you have to do with a guy like this. I just showed work because it takes more time and I need that YouTube money. Find the length of this segment indicated. So the segment that I need right here, x, is what I need to find. Let's see what I have. I have a diameter. The whole diameter is 18.8. That would make this the radius, which if the diameter is 18.8, oh, this is good news. That means the radius is going to be half the diameter. So that whole red line is going to be half of 18.8, which is 9.4. Why is that important? Because what I need to find, x, is a part of my radius, and I'm given the other part. So x plus 4.2 is my radius, which is 9.4. So in order to find x, I just subtract 4.2, subtract 4.2, and x is going to equal 5.2. And if you're wondering, then what's that 7.8 for? Nothing. I'm there to scare you. I'm there to throw you off. That's it. We're done. Find the length of the segment indicated. This looks like the Devil Wears Prada logo. Those of you metalheads, I played a show with Devil Wears Prada when I was in a band back then. That's right, I was in a band. This voice does not just get its own, forget it. All right, so this is what I need to do. Let's not overthink it. X represents a radius. What is this guy right here? A radius. So why don't we call you x? Okay, because they're the same thing. Why am I moving that x over there? Well, because I'm given two pieces of information about this guy, which is clearly a right triangle. And if I'm trying to find what appears to be the longest side of a right triangle and I give you the two shorter sides, why don't I just use Pythagorean theorem to do that? Which is what I'm going to do. So here's Pythagorean theorem. I can call u c, and it doesn't matter which one's a or b as long as the longest side is c. So I have 8.3 squared plus 4.4 squared is going to equal x squared. Now let's do a little bit of math. 8.3 squared is 68.89, according to my calculator. 4.4 squared, 19.36. My calculator, I'm using Siri, my calculator thought I just did 4 squared, which is a fun game. Now I need to add these two together. 68.89 plus 19.36 is going to be 88.25. That equals x squared. In order to get x all by itself, I have to square root both sides. And remember, usually when I square root both sides, you're thinking positive or negative thoughts, not when you're dealing with length. The square root of 88.25 is going to be 9.3941 according to Siri. Do I have any units to worry about? Nope. So all I have to do is just say x equals that guy right there. It doesn't tell me where to round it, so I'm keeping all four of those numbers. I'd like to try to see you stop me. I'd like to see you try and stop me. I give up. Like and subscribe. Find the length of the segment indicated. I need to find that x value right there. Now I have a long ways to go, but this is how I'm going to set it up. I see a radius of 15.1. I see a 12.8 over here, and this radius right there. A radius takes a chord and cuts it in half. So this radius cuts that chord in half, which means whatever this guy over here is, that guy is also 12.8. My job is to find x. If this was 5, then I would just do 15.1 minus 5 equals x. But I don't know what this is. But you know what? This is connected to a right triangle. I have a leg. I have a hypotenuse. So why don't I call you b? Because if it's a leg of a right triangle, then let's just call it b. I need to find b. Once I find b, 15 minus 1 minus it gives me my x. So let's use Pythagorean theorem. A squared plus b squared equals c squared. The longest side has to be c, so 15.1 fits that. I'll call you a because I already called b b. And so I have 12 12 point, what is that? 12.8. 12.8 squared plus b squared equals 15.1 squared. 12.8 squared is 163.84. 15.1 squared. 15.1 squared is 228.01. Now, in order to get b all by itself, I'm going to subtract 163.84 from both sides. 228.01 minus 163.84 is 64.17. Now, in order to get b all by itself, I have to square root both sides. And the square root of 64.17 is a little over 8. It's actually 8.01. It's a shame it couldn't just be 8, but it's 8.01. So b, this guy right here, is 8.01. Now, again, the whole purpose is I know this is a radius. I'm trying to find x. So in order to find x, I can do the radius, 15.1, there it is, minus the chunk that I just found, 8.01. 15.1 minus 8.01 is 7.09. So that's my x. So no units to worry about, just numbers, dunzo. Find the circumference and area of a circle, something that you learned way, way, way back in the day, but we're bringing it back. Circumference is the same thing as perimeter. The formula for circumference is 2 pi r. In this case, r is 4.2. So the circumference, and I'm going to say this so that my phone hears me, 2 times pi times 4.2, 26.3893. 26.3893. Siri's just giving me all these numbers, so I'm going to use them. Circumference is distance, so it is just yards. So don't worry about yards squared, yards cubed, nothing like that at all. Area is area, and the area formula is pi r squared. The same r, so the area is pi times 4.2 squared, which according to Steve Jobs is 55.4176 yards squared because it's area. Circumference, area, stuff you saw in middle school, bringing it back. Find the circumference of a circle with an area of 64 pi miles squared. All right, well, the area formula is pi r squared. I have to find the circumference, which means I have to find the radius of this circle. Now, if the area is pi r squared and it's giving me the area, then I'm going to say 64 pi is pi r squared. First things first, if we divide both sides by pi, which I'm about to do, the pi's on both sides cancel out. Oh, happy day. That leaves me with 64 equals the radius squared. I need the radius. How do I get rid of that squared? Square root both sides. Normally when I square root both sides to solve an equation, I attach a positive or negative symbol, but I don't care about negative, so I only care about the radius equaling 8. So the radius is 8. Now that I know the radius is 8, I can find the circumference. The circumference is given to us by the formula 2 pi r. In other words, 2 times pi times 8, which is 50.2654 miles. Fun. solve for x. What we're dealing with here is what's called an inscribed angle. Okay, we're used to seeing central angles. An inscribed angle is an angle where all three parts, the vertex primarily, is attached to the circle. Now, don't lose sleep. If I were to say A, B, C, the inscribed angle, okay, so the measure of angle ABC is going to be half of the intercepted arc, half of AC. So if AC was like, I don't know, 60, you would be 30. Okay? So the way I'm going to view this is this guy, this inscribed angle is going to be half of 192. So I made that really big. Now I have to get rid of it. I'm going to set up the equation 31x plus 3. 31x plus 3 is half of 192. So 31x plus 3 hasn't changed yet. Half of 192 is 96. Now I have a two-step equation. Minus 3, cross you out. 31x equals 93. Divide both sides by 31. Divide both sides by 31. And x equals 3. Okay, which is what I was supposed to do. Find x. Don't need to go any further. But if I wanted to check my work, I could do 31 times 3 is 93. 93 plus 3 is 96, which is half of 192, what I was trying to find in the first place. Fantastic. Find the measure of angle NLM. NLM is this guy right here. Okay. Now let's do this. I have an inscribed angle, okay? And it looks kind of like this. Remember, an inscribed angle, so whatever the angle is half of the arc that it creates. So NLM is going to be half of 7x minus 10. Here's the problem. I don't know what 7x minus 10 is. No clue. Here's what I do know. This is a straight line, which means this arc right here, arc LMN, is 180 degrees. So 13x minus 10 plus 7x minus 10 equals 180. So if I set that up, then I will be able to find out what x is, and I'll be able to find out what that angle is. So 13x minus 10 plus 7x minus 10 equals 180. Let's combine like terms. 13x and 7x make 20x. Negative 10 and negative 10 make negative 20, and I equal 180. Now it's a two-stepper. Add 20, and 20x equals 200. Divide both sides by 20, x equals 10. Am I done? No siree. Because again, what I know is the measure of angle NLM is going to be half of 7x minus 10. So let's say that the measure of angle NLM is half of 7x minus 10. Well, wait a minute. I just found out that x is 10. So 7 times 10 minus 10, which means the measure of angle NLM is going to be half of 70 minus 10, which is 60, and half of 60 is 30 degrees. That's how you do it, okay? Inscribed angle stuff, and inscribed angles are half of the angle or intercepted arc that it creates, and I had to do a little bit extra in order to get to that answer, but I had a great time doing it, and I hope you did too. Find the measure of arc FGH, which is this whole thing right here. Well, let's draw a quick picture. Let's make sense of it. Usually, and this is what I see, by the way, inscribed angle, the two pieces of information that I'm given are all inscribed angles. So let's quick talk about inscribed angles super quick. I'll call you A, I'll call you B, I'll call you C. Okay, the inscribed angle, so the measure of angle ABC is going to equal half of the measure of the intercepted arc. Half. Now, usually I'm being asked to find the measure of inscribed angles. Not in this case, I'm being asked to find the measure of the arc. So why is this important? Well, if the angle is half the arc, then the arc is twice the angle that it creates. So let me say that. The measure of angle FGH, the measure of arc FGH, which is U, is going to be 2 times the angle created by these guys right here, 2 times FAH. So the measure of angle FAH. Now, this is what I know. This is what I know. I know that I'm given information about this inscribed angle and that inscribed angle, which means I care about the arc FGH, obviously, and I care about the angle or the arc FAH, obviously. Those two are connected, and they both add up to 360 degrees. So the measure of arc FGH plus the measure of arc FAH is 360 degrees. Now I know the measure of angle FGH, or the measure of arc FGH, is 2 times, so you become 2 times the measure of angle FAH, which means you would be 2 times the measure of angle FGH. And that equals 360 degrees. I know what angle FAH is. It's 38x plus 5. I know what the measure of angle FGH is. It's 21x minus 2. And now it's just an ugly, gross, terrible algebra 2 problem. All right, so distribute. That becomes 76 plus 10. Distribute again. That becomes 42x minus 4. And 360 is still 360. Let's combine like terms. 76x and 42x is 118x. Plus 10 minus 4 is plus 6 equals 360. Subtract weird-looking 6. Subtract weird-looking 6. 118x equals 354. Divide both sides by 118. Divide both sides by 118. And x is a perfect little 3. Now, why does this matter? Because originally what I was supposed to do is find the arc measure of FGH. FGH is 2 times angle FAH. I now know that x is 3. So what I care about is 2 times 38x plus 5, where 38 times 3 is now being added to 5. 38 times 3 is 114. 114 plus 5 is 119, and twice that is 238. So the measure of arc FGH is 238 degrees. Inscribed angles are usually pretty pleasant. This problem, not so much. Determine if line AB is tangent to a circle. What is a tangent line? Well, let's say I give you a circle right here. Let's say that I put a center right there and I have a radius there. If I were to have a tangent line has to be perpendicular to the radius. Wherever that tangent line hits the circle, create the radius, it has to be perpendicular, which means you have to be a right angle right here, which means in order for this to be a tangent line, I have to show that this triangle is a right triangle. Well, what information do I have? Well, I have the fact that that radius is 12, which means this length right here is 12. I also know that this is 8, so this guy right here is 8 plus 12, which is 20. So I have a right triangle of 16, 12, and 20. So I'm going to use the converse of the Pythagorean theorem to show that this is a right triangle. So if I'm going to show that this is a right triangle, I'm going to label UA and UB, and I definitely have to label the longest side C, and I have to make sure that A squared plus B squared is for sure C squared. 12 squared plus 16 squared has to equal 20 squared. 12 squared is 144. 16 squared is 256. That's got to equal 400. 144 plus 256 is 400. Does 400 equal 400? Yes. So is AB tangent to the circle? Yes. Again, a tangent line has to be perpendicular to the radius that it hits. So in other words, since this is a right triangle, it is perpendicular because it creates a 90-degree angle. Find the segment line indicated. Assume that the lines which appear to be tangent are tangent. And if you're wondering, what's a tangent line? A tangent line is a line that hits a circle and is perpendicular to a radius. It would really be nice if I knew how to draw much better. So what this means is if this is a tangent line, then you have to be perpendicular, which means you have to be 90 degrees. Now I have to find this segment right here. I'll call you X. What do I know? I know you're 1.5 and you're 1. So that means you're 2.5. If you're my radius and the radius is 1.5, that means you're my radius and you're also 1.5. Bada bing. So I have a right triangle where I care about finding a leg. I'll call you A because you're a leg. I'll call you B because you're a leg. And I'll call you C because the hypotenuse has to be C. It doesn't matter which one's A or B. So using Pythagorean theorem, A squared plus B squared equals C squared. I called A squared 1.5, so 1.5 squared, plus B squared, which is X. So I'll leave it as B squared for now. I could have called it X squared, but too late. I already wrote it. 2.5 squared. 1.5 times 1.5 is 2.25. Plus B squared. 2.5 times 2.5 is 6.25. Subtract both sides by 2.25. Subtract both sides by 2.25. And B squared is a really simple 4. Is B all by itself? Nope. Square root it. B is 2. And since I called B X, X is 2. Okay, so tangents create 90-degree angles. And usually if it gives you something that looks like a right triangle and it tells you if it looks like it's tangent, then you create some kind of 90-degree triangle looking thing. Pythagorean theorem. We did it. We're done. Hooray. Find the perimeter of this polygon gross. Assume that the lines which appear to be tangent are tangent. So your tangent, your tangent, your tangent, your tangent. This whole line is 18.4. A chunk of it is 5.4. This whole line is 21.9. This whole line is 20.5. I've got nothing about you. This is what I know. If it tells us that lines which appear to be tangent are tangent, then we obviously care about tangents. Now, this is what we know about tangents and about tangents that seem to meet at these points out here. Tangents that meet at a point in space are congruent, which means you guys are going to be congruent. You guys are going to be congruent. You guys are going to be congruent. And these two guys are going to be congruent. So I know you're 5.4. Now that doesn't give us this guy, but we're going in the wrong direction if we try to go here. We need to work our way around counterclockwise, as gross as it is. This whole thing is 18.4. If this chunk is 5.4, then you're going to be 18.4 minus 5.4, which is 13. So this guy is 13, which makes you 13 as well. If this whole thing is 21.9, then I could subtract 13 from it to get this chunk right here. 21.9 minus 13 is 8.9, which means you're 8.9. So if this whole thing is 20.5 and you're 8.9, then this chunk right here, 20.5 minus 8.9, which is going to be 11.6, making you 11.6. Now, the reason why we had to go through that whole part of my language rigmarole is to find this whole length, which is 5.4 plus 11.6, which is 17. So the perimeter of the quadrilateral is going to be 17 plus 18.4 plus 21.9 plus 20.5. Okay, all of the blue lines added together. 17 plus 18.4 plus 21.9 plus 20.5, 77.8 according to Mr. Computer that I'm using off to the side. Okay, no craziness needed. I mean, it's a crazy problem. It's a wacky problem, but, you know, there you have it. Tangents, fun. Find the angle measure indicated. Assume that the lines which appear to be tangent are tangent. So there's only one line that appears to be tangent, and it's U. My goal is to find this fella right here. I know you're 44. So this is what I'm going to do. I have a triangle living inside this triangle. I don't know if they're similar. They're probably not. If they were similar, then this would just be 90 degrees. We call it a day, but it's never that simple. What I do see is this big triangle right here, and I have two angles already for that big triangle. I have this 90-degree angle, I have that 44-degree angle, and I have this guy, which I don't know. I'll call you X. So what I know is that 90-degree angle there in green, that 44-degree angle there off to the right, and X are going to add up to make 180 degrees because of the triangle. 90 plus 44 is 134, and now it's a one-step problem. Equals 180. I'm going to subtract 134 from both sides, minus 134, and X is going to end up being 46 whatevers degrees. Now, why do I care about that? Why is that important? Well, let's zoom out a little bit. Let's get rid of all this fluff. If you're a radius, that makes you a radius, which makes you the same, which makes you the same because of isosceles triangles. Oh, so I'll call that question mark Y. And what I know now that if you're 46 degrees and you're 46 degrees, 46 plus 46 plus I don't know, which I called Y, is going to equal 180 degrees because of triangles. 46 and 46 are 92. 92 plus Y equals 180 degrees. Let's subtract 92 from both sides. Subtract 92 from both sides. And it's going to end up equaling 88. So the missing angle measure that I care about, let's put these back so it looks nicer for when I take a screenshot and make a thumbnail for my YouTube account. We're going to end up with 88 degrees. Ooh, fun. Isn't that nice? It was super nice. Find the measure of the angle indicated. What I have here is two chords. Now, usually I play power chords on my guitar, but two chords, that's a different thing. There's a little rule that says if you have two chords, this also works for secants, and you care about that guy, and we'll call you A, and we'll call you B, and we'll call you C, and we'll call you D. There's a little rule that says if I want to find the measure of angle X here, that what you do is the measure of angle X is going to be the average, so half of arc AB plus arc CD. Okay, so basically we care about the arc that's created by these chords, right? We're not doing these guys. We just care about the I guess we want to say the intercepting arcs, but I don't even know if that's technically true. Regardless, arcless, we're going to do the same thing here. Okay, I'm going to call you X. And so X is going to be the average of 175 and 55. So do I have enough space? I might. The measure of X, so we'll just say X is going to equal 1/2 of 175 plus 55, which is going to be 1/2 times 175 plus 55 is 230, which is when I usually go to the dentist. And that ends up being 115. So the measurement that I care about, the angle measurement that I care about, question mark, is going to be 115 degrees. Chords. Find the measure of the angle indicated. These are secants, right? A secant is a line that basically has no, rhyme or reason. It's just a line that cuts through a circle. All right. Now, this secant, by cutting it through the circle, these two secants, rather, by cutting it through two circles, gives me 4 points that it cuts through. Okay. And we'll call them A, B, C, and D. Now, let's call you angle X, which is kind of what I want to do here. All right, if I'm trying to find the measure of angle X, which is an angle created by two secants, what you do is the measure of angle X is going to equal 1/2 of the large arc that's created by the two secants, the large major arc, so arc BD, minus arc AC. Okay, so close to the average, but not quite. All right, so what I'm going to do is the same thing over here. I need to find the measure of angle, I don't know, question mark, we'll call you X. So X is going to equal 1/2 of the large arc that's created. So if I were to pretend that these lines are still going on, we can see the same thing. 175 would be that guy, so 175 minus this smaller arc that's created, 75. 57. Oh, numbers. You're so difficult. I'm not sure why I got 2 degrees in them. 175 minus 57, I believe, is 118. Yep. And half of 118 is going to be 59. So X is 59, which means the measure of angle, I don't know, is going to be 59 degrees. Okay. Okay, fun. Secants. Solve for X. All right, so I've got information here, I've got information here, and I have 50 degrees. There's a little rule, and let me try to draw this rule as best as I can, where if you take two secants, okay, two secants. And that's essentially what this is. If I wanted to, I can keep these lines, I can keep them going on so these guys now look a whole lot more the same. And if I were to call you P, Q, S, and D to match up with this, and call you R, there is a rule that says if you take two secants and you have an angle created by those two secants intercepting, the measure of that angle, so the measure of angle R, is going to equal 1/2 of the larger arc that's created, so arc PD, in parentheses, minus the smaller arc that's created, QS. Okay. This problem just involves more math. I did a problem like this before where it was just numbers. Now I have a little bit of like solving equations type stuff going on. The measure of angle R, according to this picture, is 50. That's going to equal 1/2. I have to squeeze this in a little bit better. PD is 12x plus 8 minus QS. Now we have to be very careful. We have to throw these in parentheses. 4x plus 4, close it, close it. And now it's just a really, really, really ugly like equation that you would see. I still have a bunch of stuff going on in parentheses, so nothing happens with a half yet. Nothing happens with 12x yet. Nothing happens with 8 yet. But what I can do is distribute this negative to make it minus 4x minus 4. That's why it's important to put those parentheses there. Okay. Inside the parentheses, I can combine like terms. So 50 doesn't change. 1/2 also doesn't change. 12x minus 4x is 8x. 8 minus 4 is 4. And now I distribute the half. 50 equals half of 8x is 4x, and half of 4 is 2. Now it's a two-stepper. Minus 2, minus 2. Cross you out. 48 equals 4x. Divide both sides by 4. Divide both sides by 4. Let's write it up here. X equals 12. All right, so secants cross to make an angle. I'm going to take half of the difference of the two arcs that are created. Okay, make sure it's positive. The end. Find the measure of angle QPR, which is U. Now, QPR is 26x minus 2. Can't do much with that right now. What I know is I have two chords, or if you want to think about it, two secants intersecting within a circle, within the circle, not outside the circle. When you have two secants intersecting within the circle, there's a little rule that I'll write up here. Okay, and we'll call you A for angle. We'll call little a, we'll call you A, B, C, D. The rule is that the measure of angle A is going to be the average of the intersecting arcs. So the average of arc AB plus arc CD. So that's how I'm going to set this problem up. This angle is going to equal 1/2 times the quantity of 131 plus 18x plus 1. All right, so let's set that up. That's my angle right there. I already have that information. So 26x minus 2 is going to equal 1/2 of one of the arcs, so QR, so 1/2 of 131, that's a third. 1/2 of 131 plus 18x plus 1. I can combine like terms within the parentheses, so let me quick do that. So 1/2 of 132, blink 132, am I right? Plus 18x. Now we distribute that 1/2. So 26x minus 2 is still there. Half of 132 is 66, plus half of 18x is 9x. Now I have variables on both sides of the equal sign. Let's get rid of the one on the right. Minus 9x minus 9x is going to give me 15x. Ugh, this is not going to be pleasant at all. So 15x minus 2 is going to equal 66. I knew I was wrong. This is 17x. This is 17x. 17x. I knew something would be right. Which now it's going to be pleasant, because if I add 2 to both sides, that gets me 17x equals 68. Divide by 17, divide by 17, and that's going to get me x equals 4. Done? Circle it, call it a day? No, because I need the measure of angle QPR, and the measure of angle QPR is 26x minus 2. I just found out that x is 4. So 26 times 4 minus 2. 26 times 4 is 104. Minus 2 is 102. So in the little space that I have down here on the bottom right, I will write out that the measure of angle QPR is 102 degrees. Almost made a fatal mistake there, but I didn't. Find the angle measure indicated. Assume that lines which appear to be tangent are tangent. So let's take a look at this guy on the left. U appear to be tangent. So if that's a tangent line, then what I know is U are 90 degrees. This is basically an inscribed angle, or better yet, if this is 90 degrees, this cuts this guy in half, which means that right there is 180. Am I done? No, because I still need this little sliver right here. Now, this is 90 degrees as well. If you were 76, that makes this little sliver 14, which makes U 28. So the question mark is going to be 180 plus 28, which is 208 degrees, bada bing. This guy looks bad, but it's not so bad at all. There's a rule that states that in this case, the measure of angle U is going to equal the large arc. So I'll put half. It's actually half of the large arc. So I'll put B for large plus this small arc. Here's the issue. I'll call you X because that's what I'm finding, but I don't know what this is, except for the fact that this whole circle is 360. And if you are X, then this arc is going to be 360 minus X. Okay, so what I'm going to do, it's actually a minus. I knew something was wrong there. I was looking at that. I was like, oh, I'm not doing it right. It's a minus because the angle meets on the outside of the circle. Silly me, minus. All right, so what I'm going to do is I'm going to say 50, because that is the measure of angle U, is going to equal 1/2 of the big guy, which is 360 minus X, minus the small guy, which is X. So 50 equals 1/2 of 360 minus 2X. Let's distribute that 1/2. So 50 is going to equal 180 minus X. If I subtract 180 from both sides, which I'm doing right now, I get negative 130 on the left. That's going to equal negative X. And if negative X is negative 130, then positive X is positive 130, which means the question mark for this one is 130 degrees. Solve for X, assume that lines which appear tangent are a tangent. So what we have is an intersection of a tangent line and a secant line. There's a little rule that says if you have the intersection of a tangent line and a secant line, what you do is we'll call this angle A. Okay, I like to call this the far away arc, and I like to call this the near arc. The rule is the measure of angle A is going to equal 1/2 of the far arc minus the near arc. So the way that I can set this up, is my angle measure I know to be 5x minus 5. That's going to equal 1/2 of my far arc, which is 190, minus my near arc, which is 13 minus 7 in parentheses. If you don't have parentheses, things are going to go bad. 13x minus 7. Double parentheses to end it out. Before I can do anything, I have to distribute this negative, so let me do that. So now I have 5x minus 5 on the left equals 1/2 of 190 minus 13x plus 7. Ugh. This is not going to be fun at all. Not fun at all. I'll show you a trick. I'll show you my little trick. 1/2 times 190 plus 7 is now 197 minus 13x. Now that 1/2, I don't want to distribute that 1/2, so here's my trick. If I multiply both sides by 2, then these cross out, and all I have to do is distribute the 2 and everything works out. 10x minus 10 is going to equal 197 minus 13x. Okay? Now I can add 13x to both sides, which is what I'm going to do. That gets me 23x. 23x minus 10 equals 197. I'm running out of space, so I'll write it over here, all the way to the left. 23x, if I add 10 to both sides, that gets me 207. Divide both sides by 23. 207 divided by 23. Let me think. 207 divided by 23.
The answer is 9.
According to Siri. So x equals 9. Which is what I was supposed to do. Gross, that looks awful. Ugh. I'm having a little lag issues on my computer right now. And I'm towards the end of making like a bunch of videos, so I don't want to reset it now. But that's how you do it. X is 9, not the prettiest problem in the world, but it's done. Looks like a party hat. Doesn't look like a party hat. It's a guy going to a party. Or a bird. Maybe it looks like a bird. Solve for x. All right, I have two chords intersecting within a circle. There's a little rule that says if you have two chords intersecting within a circle, call the segments in one line AB, call the segments in the other line CD, and AB is going to equal CD. So over here, you would be like my AB, so x times 4 is 4x, and you would be my CD, so 5 times 8 is 40. Divide by 4, x is equal to 10, dunzo funzo. Solve for x. I have two chords intersecting within a circle. There's a little rule that says if you have two chords intersecting within a circle, call the two parts of one chord AB and call the other two parts of the other chord CD. And A times B is going to equal C times D. Now, what does that mean here? I have to do a teensy bit of work. If you are my one chord connected, 4x plus 2 times 8 is going to look like this. So I'll do 8 times 4x plus 2, so it looks like distributive property. It's prettier that way. And then 9 times 4x. 8 times 4x is 32x, which is a video game system from back in the 90s. 8 times 2 is 16. And 9 times 4x is 36x. X on both sides of the equal sign. I want to keep it positive. Plus, there's no number over here, so it would be stupid for me to subtract 36x from both sides. So I'll subtract 32x from both sides. Just like the country subtracted 36x, 32. Forget it. I'm just trying to make a joke. That's going to equal 4x. So 16 equals 4x. Divide both sides by 4. Divide both sides by 4. X equals 4, and that's exactly what I'm supposed to do. So there you have it. X is 4. Fun. Find CE. All right, what do we have here? We have two secants intersecting inside of a circle to make two chords and then stuff on the outside. Usually when we see two secants, we're thinking, oh, this angle is going to be a 1/2 of that arc minus that arc. Simple. No, we are finding measurements here. There is a rule that says if you have two secants which hit a circle and create two chords and then the outer parts here, what you do is you take the entire secant. So I'm looking on this guy on the left, the entire secant, and multiply the outside part. So SE times FE is going to equal the entire secant, which is CE times DE. So let's plug in what we have. SE is going to be 10 plus 8, which is 18. I can do that. FE is 8. I can do that. That's going to equal CE. Not so pleasant, this one. 2x minus 17 plus 9. So 2x minus 17 plus 9. I'll simplify that in a minute. And DE is 9. Okay. 18 times 8. 18 times 8. According to my watch, is
that would be 144.
Thank you, watch. Now I have 2x minus 17 plus 9 is minus 8. So multiply that to 9. So that's distributive property right there. So 144 on the left is unphased. So I have 9 times 2x, which is 18x. 9 times negative 8, which is minus 72. Now it's a two-stepper. I'm going to add 72 to both sides. I'm going to add 72 to both sides. And you become 216. That equals 18x. Divide both sides by 18. And let me see. I'm just going to use my watch again. 216 divided by 18.
That would be 12.
So x is 12. Am I done? Nar. Because my job is to find CE. CE is 2x minus 7 minus 9. You were CE right there. So CE is 2 times 12 minus 8. 2 times 12 is 24. 24 minus 8 is 16. So CE is 16. No units. That's my guy. I am done.